Next thing I want to take a look at, coterminal angles. Coterminal angles are angles that have the same initial ray and terminal ray. For example, if I have an angle that looks like this, I'm starting here, I'm spinning over here, and it's going to end up over there. Versus an angle that looks like this. I'm going to start here, I'm going to spin the opposite direction, and I'm going to end up over there. Both angles end up in the same place. They're different angles because remember, an angle is not just about where you end up, but also how you got there, how you spun. I spun this little amount counterclockwise. Here I spun this bigger amount clockwise. But we call those angles coterminal if our initial ray, where we're starting, and our terminal ray are in the same place. To find coterminal angles, all we need to do, so a couple other things. I've got this angle over here. Another angle that is coterminal to it is the angle that starts here, spins all the way around, and then a little bit more to end up over there. If you spin all the way around, that's 2 pi. If I take the initial angle that I have, add a complete spin around the unit circle to it, I'll end up in the same place. That angle's a different angle, but it puts me in the same place, and I call those angles coterminal angles. To find coterminal angles, all we need to do is add or subtract 2 pi as many times as we'd like. To determine coterminal angles, add or subtract 2 pi, or 360, but we're going to stick with radians in here, as many times as you'd like. So the first thing I want to do is find some angles, 2 angles that are coterminal with 5 pi over 6. I want to find one positive one, one negative one. Well, to find a positive one, all I have to do is add 2 pi to this. But that's kind of unpleasant the way I have it. I need to get a common denominator. Well, 2 pi over 1 is the same as saying 12 pi over 6. So why don't I do 5 pi over 6 plus 12 pi over 6? And that's going to give me 17 pi over 6. I can keep adding 12 pi over 6 to get more and more positive coterminal angles, but let's try to get a negative coterminal angle. I can do 5 pi over 6 minus 2 pi, and let's jump straight into just subtracting 12 pi over 6. I can get negative 7 pi over 6, and those are coterminal angles with 5 pi over 6. I know that 5 pi over 6 is the angle over here. 17 pi over 6 would be go all the way around and then end up over there. Negative 7 pi over 6 would mean start over here and spin in the opposite direction and end up over there. They all start and end in the same place. You just get there a different way. The reason I'm reviewing this with you is because oftentimes we'll need to find the sine, cosine, tangent, whatever, of angles that are bigger than 2 pi or angles that are less than 0. All we need to do is find a coterminal angle and then find the sine, cosine, tangent, whatever, of that angle. Let's take a look at this one. Let's do the cosine of 13 pi over 4. That is bigger than 2 pi. 2 pi would be 8 pi over 4. So the first thing I want to do is find a coterminal angle. Okay, so 13 pi over 4. I feel like adding 2 pi, adding 8 pi over 4 is not going to help me because I want an angle between 0 and 2 pi, one of my good angles around the unit circle. So let me subtract 2 pi, or really let me subtract 8 pi over 4. 13 pi over 4 minus 8 pi over 4, that's 5 pi over 4. Because these angles will end up having the same initial ray and terminal ray, their cosines are going to be the same. The cosine of 13 pi over 4 is the same as the cosine of 5 pi over 4. Why? Because 5 pi over 4 is the angle that spins over to here, while 13 pi over 4 is the angle that spins all the way around and then a little more and still ends up in the same place. All I need to do is now pick out the cosine, the x-coordinate of this point. Well, I'm in quadrant 3. My cosine is negative, and it's the one right in the middle. My cosine is going to be negative root 2 over 2. And that's what we do if I give you an angle that's too big or too small. We'll find a coterminal angle that is between 0 and 2 pi, and then we'll just use what we've already talked about with that. Let's try another. Let's try the sine of 13 pi over 3. Too big. Let me find a coterminal angle by subtracting 2 pi. Instead of 2 pi, let me just call it 6 pi over 3. And that's going to give me the sine of 7 pi over 3. You know what? That's still a little too big. That's still bigger than 2 pi. Let me do it again. Let me subtract another 6 pi over 3. And I'm going to get just pi over 3. All three of these will have the same sign. Okay, so I was looking for a sine. I'm going to go to my unit circle. I want the sine of, nope, not that one. I want the sine of this angle. I want the y-coordinate of this angle. I think my y-coordinate over there, 1/2 root 2 over 2 root 3 over 2, I think my y-coordinate is root 3 over 2. And of course, we can also do this with the other trig functions. Let me get another piece of paper. Okay. What about the tangent of negative pi over 6? Well, there are two ways we can deal with this one. First way we can deal with this is just find a coterminal angle. So negative pi over 6 plus 2 pi plus 12 pi over 6 is going to give me 11 pi over 6. I could just find the tangent of 11 pi over 6, which is the angle that's over here. Another way of thinking about this, though, is I know that pi over 6 is starting here and spinning counterclockwise up to here. Negative pi over 6 is spinning the same amount in the clockwise direction. So where is negative pi over 6? Right over here. If you can just locate this point and then find your sine and cosine, your x and y coordinates of this point, that'll work. Or if you don't like that, we can do that coterminal work, and we've already turned it into 11 pi over 6. Either way, I want my sine and I want my cosine. My sine of 11 pi over 6, or negative pi over 6, looks like my y-coordinate, negative 1/2. My cosine is my x-coordinate, root 3 over 2. This is going to be negative 1/2 over root 3 over 2. I'll do my simplifying. This is negative 1/2 times 2 over root 3. That's negative 1 over root 3. I'll rationalize. It's a good thing. Why not? Negative root 3 over 3. One last one. Let's do the cosecant of negative 3 pi over 4. Two ways to think about this. I know that 3 pi over 4 is over here, so I want to spin the same amount in a negative direction. That'll put me over here. What is that angle, though? One time around the unit circle, I guess I could find a coterminal angle to this. I could say negative 3 pi over 4 plus 8 pi over 4. I could say it's 5 pi over 4 and deal with this as the cosecant of 5 pi over 4. I don't care if you think about it as negative 3 pi over 4 or 5 pi over 4, it puts you in the same place. How do we do the cosecant? It's 1 over the sine. 1 over the sine of 5 pi over 4. Okay, well, what's the sine of 5 pi over 4? What's the y-coordinate over here? Negative root 2 over 2. Let's clean it up. This is 1 over 1 times 2 over negative root 2. That is negative 2 over root 2. We'll rationalize. We're going to get negative 2 root 2 over 2. We're going to get negative root 2 for that one.